Good day, students. So welcome to part 2 of the Algebra 2 Trigonometry Regents exam for June 2013. In this installment, we're going to be going over questions 6 through 10. All right, so question number 6 says, which equation represents the graph below? So there are two main things you want to keep in mind or recall when writing down the function that represents a trigonometric curve. First of all, if you're dealing with sine and cosine, really, you need to remember what the orientation of a period of a sine and a cosine function look like. So let's say you have y equals sine x. So you have to remember that for the sine function, starting from the origin, it's like an S, okay? It's like an S going up for the positive sine function. And then for the negative sine function, let's do that in red, it's like an S going down. So this is one complete period, okay? All right, so this is positive right here for positive sign, and this is negative sign. And then for the cosine situation, it's like a cup, the cup opening up for the positive cosine. That's one complete period. And then for the negative cosine, it's like a cup facing down, okay? So that's for one complete period. All right, so this is negative. Okay, so cosine always starts from the max if it's positive and the mean if it's negative. Sine always starts from the origin and goes up if it's positive and goes down if it's negative, okay? And another thing you have to remember, other than the orientations, is that uh, a the parent function of a trig curve, sine and cosine, can be written as y equals a. It could be sine or cosine. Let's just use sine bx. Okay, this is the case where there is no translation in the vertical or horizontal direction. Just either vertical or horizontal compressions happening here. So this could be sine or this could be cosine. All right, and you need to remember that a is the amplitude, the displacement in the horizontal direction, and b, um, 2 pi over b is a period. Okay, so period, and then b is basically 2 pi divided by the period. All right, so you have to be careful with this. This is the one that most people make the most mistakes with. They misinterpret the period and b. They're not the same thing. 2 pi over the period is b, and if you want to get the period, you do 2 pi over b. Okay. All right, so let's use this pieces of information to see if we can determine the right equation for this trig function right here. If you notice, it starts from a minimum and it's like an upside down cup for one complete period, okay? So that automatically tells me that it's not sine because sine always starts from the origin um, and goes up or down. This one starts from the minimum. So it's going to be a cosine curve. So remember, cosine, positive cosine starts from the max and negative cosine starts from the min. So we can automatically tell that this is going to be a negative cosine function, all right? So it's not positive, it's a negative cosine. So we can eliminate options 1 and 2. It's not negative sign. So it's either going to be y equals negative 2 cosine 2x or y equals negative 2 cosine 1 over 2x. Okay? So the amplitude is clearly 2 because the displacement from the central position is 2 units up and down. Now, what is b? The b that fits, so let's write out the function that we're going to be using here. The function that we're using is y equals a cosine bx. Okay, so we know a is negative 2. We just need to figure out what the coefficient of x is. What is b? So remember the formula, b is 2 pi over the period. Okay, so what is the period of this function? Take a look at this problem. One complete cycle, minimum heading up to minimum heading up is pi. So period is pi. So this implies that b is going to be 2 pi over pi. Okay, so 2 pi over pi, divided out the pi's, you're left with 2. So your b is 2. So the equation is going to be y equals that negative, because it's starting from the minimum. A is 2 cosine 2x. Okay, so we can clearly see that our answer is option number 3. All right, let's take a look at question number 7. So question number 7 is an absolute value inequality problem. Now, one thing you can determine just by examining absolute value inequality problems is the orientation of the inequality. Okay, anytime you have an absolute value inequality that is greater than, you can never have a bounded region as your solution. It's impossible. Okay, it's only when you have less than. So since this is greater, I can automatically eliminate these two because these two are of the form ax plus b could be plus or minus b is less than c. Okay, so if the absolute value quantity has a less than after it, you're guaranteed to have a bounded solution region. But if it's greater than, there's no way you can have a bounded solution region. So it cannot be 2 and it cannot be 4. Our answers must be 1 or 3. Okay, so that's just a little trick to keep in mind. So let's go ahead and solve this to show you that our answers cannot be any of these two. So we have absolute value of 2x minus 1 is greater than 5. So the definition of absolute value is the distance from 0 in both directions. So this basically says this quantity is, the measure of this quantity from 5 is in both directions. Um, it has to be greater than 5 in both directions, okay? So using the definition of absolute value, since it involves two directions, we'll replace the absolute value with plus or minus. Since we're going in both directions, 2x minus 5, we're measuring our distance from 5, being greater than 5. So plus or minus 2x minus 1 has to be greater than 5. So we're going to split this equation. This is two equations in one, okay? The first equation is negative 2x minus 1 is greater than 5, or we have 2x minus 1 is greater than 5. This is a positive component and this is a negative component, all right? So on the left side, let's solve this first. Distribute the minus. You have negative 2x plus 1 is greater than 5. Subtract 1 from both sides. You have negative 2x is greater than 4. Divide both sides by negative 2. So don't forget, anytime you divide an inequality by negative, you have to switch the inequality symbol. So this is going to be less than negative 2. Alright, so we can see that our answer is automatically going to be option 1. Okay? Because this has a wrong solution. Anyway, let's shift our attention here and solve this for x. So you add 1 to both sides. Add 1, add 1. And then you have 2x is greater than 6. And you divide both sides by 2. And you have x is greater than 3. Okay? So let's graph this. X is less than negative 2 or x is greater than 3. Graph this on a number line. So we have negative 2 and 3. Just follow the direction of the inequality. Less than, you're going in this direction. And then greater than, you're going in that direction. Now, why on earth did they put this as an option? Why is this a good distraction? That's the question. The reason why this is a good distractor or distraction is that when you're solving this, most people fail to distribute the minus to both quantities in the parentheses. So let's assume that you forgot to distribute this minus to the 2x. You have negative 2x minus 1. And then when you add 1 to both sides, this becomes 6. You divide by negative 2, you get negative 3. Okay? So this is a trick that catches people who do not accurately apply the distributive property when resolving this negativity of this quantity right here. Okay? So you have to be really careful. Anytime you have a minus in front of a quantity, you should distribute that sign to every term in the quantity. Okay? Alright, so there you have it. The answer for number 7 is option 1. Alright, let's take a look at question 8. It says, what is the range of the function below? So we can take this opportunity to go over the whole idea of range and domain. The domain is on the x, okay, do not forget, and the range is on the y. Alright, so the domain is what region does this graph span when it's projected on the x-axis. So if I shine a torch on this curve from beneath here, like I flash a torch on it, what is the projection of this curve on the x-axis? Or how far does it span? How wide does it span on the x-axis? If I project this curve on the x-axis, it's going to be a line going in this direction, okay? Since it starts from the origin. So that tells me that the domain is going to be x is starting from 0 and greater, so x is greater than or equal to 0, since we do not have an open circle here. What would the range be though? The range is going to be what is the horizontal, is the projection on the vertical axis. So let's say I have a torchlight, and I flash it on this curve right here. What would the projection be on the y-axis? That's the question. So if you project this graph on the y-axis, you're gonna have something like this. So basically, you're asking how high does this what is the vertical span of this graph? How high does it go and how low does it go? That's what the range is, okay? So as you can clearly see, the vertical span of this graph starts from 0, and since the graph descends down to infinity, goes down to negative infinity, okay? So how do you express that using inequality notation? Y is less than or equal to 0, okay? Because you have a closed dot here. Imagine this is a number line. This is positive x, positive y, and this is negative y. So if you're going down, it's less than. If you're going up, it's greater than. So this is the range, all right? So the question asks us for the range. So we can clearly see that our answer is option option number 3, okay? So some people confuse domain and range, and if they had that confusion, then they'll pick option 2, which is the domain, but it's asking for range, so we just focus our attention on the y projection or vertical span. All right, so there you have it. All right, let's take a look at question number 9. It says the expression sine theta plus 90 degrees is equivalent to. So this is a translation um, along the horizontal axis or the x-axis, okay? So what kind of translation is this? Since it's grouped with the x, plus 90 degrees basically involves a 90-degree shift to the 90-degree shift to the left. Okay, you do the opposite. All right. So what we're going to do is we're going to sketch our original parent sine function, and then we're going to apply a 90-degree shift in the horizontal direction, okay? All right, so the independent variable, or x, this is theta, you can view it as x, and this is y. All right, so what we have here, let's sketch our parent sine function. Remember, the sine is like an S, so let's do that. So the parent sine function starts from the center. All right, no, this is 90 degrees, this is 180, 270, 360. The typical sine function starts from the center, goes up, comes back to the center, through the center. So this is your sine function, like the s going up, positive sine function. Plus 90 degrees basically means that you're going to shift your starting point 90 degrees to the left. Okay, so since this is negative 90 degrees, this is where you're going to start your sine curve orientation. So technically this becomes your new y-axis. Okay, so we're going to start to draw our sine curve from here. So let's do that. So this is the actual sine curve we're looking at. So it's going to go up to that point right there. This max gets shifted here and then through this point like that, and to the mid, and then so all the points basically shift one tick mark to the left. Okay, it's not perfect, but yeah, this one gets shifted there, this gets shifted here, um, this gets shifted there, and then this point gets shifted here. Okay, so you see there's a shift to the left, 90 by 90 degrees. Okay, so this new curve that we have, this black curve right here, is a function sine theta plus 90 degrees. Okay, so what does this look like? What function is this? If I extend it, it starts from the max. We talked about this earlier, and it looks like a cup, right? So which function starts from the max and looks like a cup? It is the cosine function. The sine 90, sin theta plus 90 degrees is exactly the same as a cosine theta function. Okay, if we graph cosine theta, this is exactly what it will look like. So we can clearly see that our answer is option number 4. Okay? Alright, so if this method is too abstract for you, since you're free to you can use your graphing calculator to, on this test, you can also make use of that. So all you just simply do is you graph this function and then graph the other ones next to it and see which one matches. So anyone that has is a perfect match, that will be your solution. Okay, so let's go to the Y menu. We want to enter the graph of the function. First of all, make sure your mode is set to degree measure because we're going to be working with degrees here, as you can see. Degree, and then press the Y, and you're going to enter sine X is the default independent variable in this graphing menu. So don't try and force in theta or else you get an error message. Okay, it automatically determines what the independent variable is when you're in this format. Okay, in this function. All right, so y equals sine x plus 90. All right, enter and then graph. All right, there you have it. This is the standard zoom. Okay, this is standard. Okay, so if you graph this using the standard zoom setting, this is what you will get. You get a horizontal line, which is not what we're looking for. So you have, since we deal with the trig function, you have to zoom this using the trig zoom menu. So zoom, if you need perfect sine and cosine curves, you have to use the 7 option for zoom, okay, which is the trig zoom. All right, so scroll down to 7 and press enter, or just hit 7 in your zoom menu options, and you see this nice curve. So this is the graph of sine x plus 90 or theta plus 90 degrees. So what you basically do is you go back to your y and you enter these different curves. See which one matches perfectly. Okay, so negative sine x is the first option. Enter. Let's graph it and see if it overlaps. Boom, that's a fail. It doesn't overlap. Okay. So you go back and you try all of them. So what I'm going to do, I'm going to be lazy here. I'm going to jump to the correct answer, which is cosine x. If we have a perfect overlap, then that's the answer. Okay. So cosine x, which was the answer we selected. Enter, graph. There goes the first one. It's regraphing it. And then there goes the second one. Okay, you want to be sure that it actually graphed the second one, you can go to the Y option. This one that is graphing right here, see that you move your cursor to the left of the Y and hit enter to toggle the graph type, okay? The format of the graph. So this is line format. You can change it to thick line, you can change it to shaded, greater, lessen, or a line uh, with a moving circle around in front of it. Okay, so it basically animates the path that the graph sweeps while it's graphing it. Okay, so we're gonna watch out for that circle, see what path it's following. If it follows the path of the original graph, then that's the right answer. Okay, so let's graph it. There goes the first one, and then let's see where the leading ring goes through. So that's the graph of the second one. You see how it lines up perfectly with the first one. You want to make sure that we have the right answer there. So you see it lines it perfectly. So the two graphs lay on top of each other perfectly, so we know that the answer is option 4. All right, so you can do this manually, or you can use your graphing calculator, whichever one you end up with option 4 as your answer. All right, let's take a look at question 10. It says the points 2, 3, 4, and 3 over 4 and 6D lie on the graph of a function. If y is inversely proportional to the square of x, what is the value of d? So if y is inversely proportional to the square of x, um, basically we can write that using the equation y equals k constant of proportionality over x squared. Okay? If you have inverse proportionality, one variable is going to be on top and the other variable is going to be on the bottom. All right? If it's direct variation, then direct proportionality, then the two variables will be on the top of both sides of the equation. Okay, so the inverse is why the x squared is downstairs here. If we were direct, the x will be up there. Okay, so this is an equation that tells me that y is inversely proportional to the inverse. It's inversely proportional to the square of x. All right. So in order for us to determine the output for any specific input, we need to determine what k is. All right, the value of k, which is a constant of proportionality. So in this case, we have a point that we can use. We can either use this point or this point, it doesn't matter. This looks nicer because it doesn't have any fractions. So let's use this point to determine our constant of proportionality. We'll have a rule to generate the output d for the point 6 comma d. Okay, so we want to find k first. So to find k, we're just going to plug in this value for x and this value for y. So you have 3 equals k over 2 squared. Okay, so that gives us 3 equals k over 4. Multiply both sides by 4. And then you have k plus 12. Okay, so that's a constant of proportionality. Now we can generate any output for any specific input because we have a complete function. Okay, so the function that we're dealing with right now is y equals 12 over x squared. So when x is 6, we want to find d. D is basically what y is. Okay, so let's find what that is. So y is going to be 12 over 6 squared. Okay, so there's going to be 12. 6 squared is 36. Divide top and bottom by 12, you end up with 1 over 3. And that's your output. Okay, that's the value of d. So d is basically 1/3. You can clearly see that the answer is option number 2. So there you have it. But thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking here. And please post a comment to let me know what you think about this presentation. If you have any questions, comments, or concerns, and give it a thumbs up if you liked it. More clips can be found on microserve.com/testprep. Or you can scan this QR code for direct access to this collection of review series for the New York Regents exam. Thanks again for watching and have a wonderful day.